Hi there, my name is Tom Tullis. I'm the owner of Fat Dragon Games, and we are just one of many companies here on DrivethruRPG and Wargame Vault that offer models for you to download and print yourself on a home 3D printer. Now, if you've never had any experience with 3D printing, it can be a little daunting. There are going to be a lot of terms that you maybe don't understand. You're going to see a whole bunch of different printers on the market and not know where to start. So this video is designed to answer some of the more commonly asked questions and concerns people have when getting into the hobby. I'll talk a little bit about what your options are for a home 3D printer. And finally, I'm going to show you what the print process is for taking a model that you've downloaded here on DrivethruRPG or Wargame Vault and getting it ready to run out on your brand new printer. Okay, common questions and concerns I get asked as a business owner in this industry. Probably the most common question I get is, can I really get into the hobby and make high quality miniatures and terrain for not a lot of money? And the answer is yes, you can. Most low price printers will not do they'll do a good job, they won't do an outstanding job. The one exception to that currently is the Creality Ender 3. This machine is a fantastic starter printer. I really cannot recommend it high enough. It is only $230 and it will produce skeleton miniatures like this one here, dungeon terrain, out of the box with no modifications. So again, it's a very high quality printer. It creates prints that are every bit as good or better than machines I have that run thousands of dollars. So again, fantastic starter printer can be got for about $230. Beyond that, people want to know, is it safe? Can I operate a printer like this at home, have myself around it, my kids, my pets? Is it going to cause any health issues, or is there anything to be concerned about? Well, the answer to that is it depends what you feed into it. The printer itself is not giving off anything toxic. Where the potential health hazard comes from is what type of plastic you're going to use to make your prints. Now, fortunately, the best type of plastic suited for small detail work is known as PLA. That stands for polylactic acid, and it's a bioplastic. That means it's made from cornstarch and sugar cane. There is nothing toxic in the makeup of this type of plastic. It's very safe to use at home. If you stick with this, and again, if you're printing for tabletop use, miniatures and terrain, this is what you want to use anyways. There's nothing else really suitable that's going to do as good of a job as PLA. So if you stick with this, you won't have any problems. Now, there's other filaments this machine will run. You're going to see options like ABS, which has some toxic chemicals in its makeup, and some of the more exotic flex filaments and stuff that require very high temperatures and have some things in them that may prove to be an irritant when heated and if they give off a gas. As I said, those type of materials are not suited for small detail work like miniatures and terrain, so just don't use them. If you stick with PLA, you're not going to have a problem and it will be very safe to use in a home environment. Next question I usually get asked is, am I going to see a huge surge on my electric bill using this? No. I run multiple ones of these, have not seen one. I've done some research on it on the internet, which may or may not be accurate, but most things I found agree. A printer this size, this style of FTM printer, is going to use about the same electricity as a single 60-watt incandescent light bulb left on for the same amount of time. So again, it'd be like leaving a desk lamp on for however long you're running it. It's not going to be noticeable unless you're running a lot of printers all at the same time 24/7, and then you might notice some difference in your electric bill. Beyond that, people are concerned about maintenance. I get asked about how do you keep this thing running. Sure, it works great when you first get it, but what about a year from now? Do I have to be an engineer to keep this thing up and running and still making good prints? The answer is no. These machines are very easy to maintain, and even if something does go wrong on it, in most cases, such as this one here, they're very easy to do repairs on. Maintenance for this, or general upkeep, just simply includes common sense things like keeping it clean. This has a lot of moving surfaces. Those surfaces have very tight tolerances. So if you let dust and dirt and grime build up on them, it's going to interfere with that and you will see a decrease in print quality. So what do? Once a week, go through with a paper towel or an old sock, just put a little isopropyl alcohol in it and wipe everything down. Keep it clean. Again, common sense. Beyond that, once a month, there's a few metal surfaces that have a lot of metal on metal contact. You're going to want to take some thin weight machine oil, same type of thing you would use on a sewing machine, and put a drop of oil in a couple of places. Again, easy to do, anybody can do it. Finally, to keep a machine like this is a Cartesian FDM printer, and I want to talk more about that in a little bit. They run on a belt system. They have rubber belts that move all of the moving parts and carriages. Those belts must be kept properly tensioned. They have to be nice and tight, not too tight, but tight enough without any slack in order to be accurate and create nice prints. So usually once a month when you're oiling the machine and cleaning it off, you're going to want to check belt tension. How do you do that? Just give it a little twang with your finger. If it's like a guitar string, nice and tight, you're good. If it's got slop in it or droop, you're going to want to tighten it up. Easy to do. The belts at the end of them here and here have what's known as a tensioner. This is just a pulley mounted on a movable metal frame. You'll loosen these two bolts, pull the tensioner a little tighter, tighten the bolts. Do the same here, you're done. Right there is pretty much everything you need to do to keep this machine running well. Now, if you do have a problem with it, again, this style of printer, Cartesian FDM printer, all of the components are on the exterior for the most part. So that means they're also very easy to swap out with replacements if something goes wrong. Motors do wear out. Fans do wear out. In this case, if I had a motor that ran out or went out on this machine, it's 4 screws that holds it in. You would unplug the electric wiring. It has a little white plug on it. Undo your 4 bolts, pull it off, put your new one on, and plug it back in. You could be changed out in a few minutes. Again, it's not that big of a deal. Anybody can do it if you can work a screwdriver or a hex wrench. Other questions I get asked, people are concerned about print times with 3D printing. Now, this is slow. This is not like running a paper out on your laser printer. You're not going to hit a button and 2 minutes later have a finished print. It just doesn't work that way. So, what are the print times going to look like? Well, with this Ender 3, I printed out this 28mm skeleton miniature in just under 1 hour. It's 59 minutes total. A standard dungeon wall tile is going to run about 2.5 hours. So, yeah, it's going to take a little bit, but let's take a look at this. It's really not as bad as it may seem. For a standard dungeon wall tile, let's say it takes 2.5 hours. You're going to print 8 a day. Well, after a week, you've got more than 50. After a month, you've got more than 200. So, yeah, you're not going to have instant dungeons the day you get the printer, but once you get started and a few weeks under your belt, you're going to have a very large collection of dungeon terrain. And then you're just printing things to supplement it. Now, that is the one downside to 3D printing at home. Let's talk about the upsides, the benefits you're going to get. Well, to start with, cost. 28mm skeleton like this costs 7 cents in plastic to print. So once you've bought the printer, the consumables are very, very cheap. 7 cents for this miniature. A standard dungeon wall tile is going to run about 38 to 40 cents. Again, incredibly cheap. You can build a massive tabletop layout for not much money. That's the first benefit. Second benefit is the control it gives you. When you buy store-bought terrain and you get this big box of all these pieces, well, maybe you don't need all of them. Maybe some of them you don't want, but you had to buy them because they came in the box. Maybe the box came with 10 of a certain piece and you need 12 of them for tonight's game. Well, that means you have to go out and buy a whole nother box of terrain with a lot of things you don't need just to get the 2 things that you do. With 3D printing, you only print what you need when you need it. That is incredible. It puts so much control and power in your hands over your expenses and what you put on your tabletop. Also, you can go ahead and buy the STL files, which are the digital files to run out on this, and just create a massive terrain library on your hard drive on your computer. And then when you need something, you just pull up a file and print it out. That is so cool to know that sitting on my computer is this huge library of terrain and miniatures, and it's just waiting there for me to print out whenever I want it. So the benefits of 3D printing at home far outweigh the one slight hassle of just taking a little time. But again, to print a gorgeous quality miniature in an hour or a dungeon tile and wall in 2.5, that really is not that bad. It's not like you're sitting here with it and actually building it. You're just hitting a button to print and going off and reading a book or watching TV. The printer is going to do the work for you. So again, it's not that bad. It may not be as fast as we would all like, but the benefits far outweigh that one issue. Okay, so you want to buy a printer for at home, but you don't know where to start. Well, let's look at what the different types of printers are. For home use, most printers fall into two categories, resin or FDM. Now, I don't really advise getting a resin printer for your first printer. Resin printers use a photopolymerization process to make their prints. That just means they use a liquid resin that is light sensitive, and at a specific wavelength of light, it will harden. So the printers, either an SLA, which stands for stereolithographic, or DLP, which stands for digital light projection, each use a different mechanical method for exposing that liquid resin to the necessary wavelength of light to harden it. Now, why don't I recommend them? Are they no good? No, they're great. They produce phenomenally detailed prints. They are probably the best miniature printer you can get. But here are some of the drawbacks. First and foremost, a single liter of resin is going to run maybe $100, $150. So it is very cost prohibitive if you want to do anything large. If you wanted to do a big tabletop dungeon layout, it would be way too expensive. It's pretty much suited for doing small items. Now, in addition to that, the things I don't personally like about it is the resin itself cannot be handled in the uncured liquid state. It cannot get on your bare skin. You must have gloves on when dealing with the printer and the resins. Also, you're going to have an alcohol wash station set up for taking the finished prints out of the printer, washing any uncured resin off before they can be safely handled with bare hands. Again, it's a little more hassle. Finally, the resins themselves give off odors that are irritants. A lot of people find them very bothersome, so you're going to need a very good ventilation system set up to use these printers. All of these things really add up to being something that is more for an experienced 3D printer user. It's just not something I think is a good choice for you just getting into the hobby. I don't have any in my office. I stick with FDM. Okay, FDM. FDM simply stands for Fused Deposition Modeling. That's just a really fancy way of saying it's going to take this spool of plastic, melt it, extrude it out in a layer on this build surface. It's then going to build one layer after the other until you have a finished model. Now, FDM printers come in two types, Delta and Cartesian. Delta are simply round towers that use 3 gantries with 3 arms that come down to suspend the print head. That print head is swung around like a pendulum on a round build surface. These are not nearly as common as Cartesian. Why is that? Well, the build volume is not nearly as big compared to the size of the printer as you'll get with a Cartesian printer. So Deltas do produce very nice results, there's just not many to pick from. By and large, Cartesian printers are the most popular home 3D printer on the market today. Why is it called Cartesian? Well, Cartesian simply refers to the Cartesian mathematical coordinate system of describing the location of an object in a 3-dimensional space by using 3 coordinates, x for left to right, y for front to back, z for up and down. The Cartesian printer operates along those same axes. The print head is going to move left to right on the x-axis, the print bed is going to move back to front on the y-axis, and the print assembly is going to move up and down on the z-axis. X, Y, Z, Cartesian coordinates. Features you should look for when buying a printer. First and foremost, all metal frame. If you get a printer with a plastic frame, over the life of the printer, that plastic can twist and bow, and it will throw off the dimensional accuracy of the printer, which means your print quality is going to decrease. An all metal frame won't do that. It's going to be the same 2 years from now as it is today getting it out of the box. Aside from that, a heated bed is something you really must insist on. Some printers do not have a heated bed. Do you need it to make a 3D model? No. But you do need it to make a really nice looking 3D model. What is it? Well, when you extrude molten plastic out on the print surface, it's going to cool. As it cools, it contracts. If it contracts too quickly, it's going to warp and bend, and that's going to produce a bad looking model. So what you want to do is have a heated build surface that slows down the cooling process, which slows the contraction and eliminates warping. So heated bed is not essential to 3D printing, but you do want it if you want to produce a really nice 3D print. Beyond that, open choice filament. Some 3D printers require you to use their own proprietary filament. That locks you in only to the colors they offer and the prices they want to charge, and in most cases you're going to pay more than you will for open source filament. The printers I recommend both allow you to buy any brand of filament you want, provided it's the right diameter. In the case of the two I've recommended, 1.75 millimeter diameter. By being able to have open choice filament, you can choose, you can shop for sales, you can find that perfect color in a certain brand, whatever. But don't lock yourself into proprietary filament, you will regret it. Beyond that, resolution really is not an issue anymore. It used to be, because only certain printers would go down as low as 0.1 or 1/10 of a millimeter layer height. What that simply means is when you print the models, they're in layers. The layer height determines the quality of the model. The thinner the layers, the better looking your model is going to be. Generally, you're not going to go below 0.1 or 1/10 of a millimeter layer height because it would just take excruciatingly long to print anything. The models I've shown, the dungeon walls, are printed at 0.2 or 1/5 of a layer, or 1/5 of a millimeter layer height. The skeleton is printed at 0.1 or 1/10 of a millimeter layer height. The smaller the number, the thinner the layers, but conversely, the longer it's going to take to print. That's why I print small items like the skeleton at finer layers and larger things like dungeon terrain at a little bit thicker layers. But most printers on the market are going to go at least down to 0.1 millimeter layer height, and that's enough to get started with. If you can get a printer that goes smaller, that's just even better. Now, some things that are, well, one thing that is not essential to the print process, but that I really like on a printer, is a removable build surface. What is that? Well, if you have a fixed build plate, you print your model, you're going to have to get that model off when it's done. It's going to be stuck to the build plate. You're just going to use a metal spatula to get under and pry it and pop it off. If you have a removable surface, you don't have to do that. You just lift the surface off, flex it, and your models pop off. It's just nice to have. It has no bearing on the quality of the model you print, but it is something that is really going to make your life a lot easier. Both of the printers I recommend have removable, flexible build surfaces. Now, things that are not essential to the print process, but you may want, one is automatic bed leveling. What is that? Well, for the printer to make a successful print, the print surface must be level. That means as it's extruding out, it must have an even surface to print on. If that bed is tilted one way or the other or has any warping to it, that's going to hinder that build process. Automatic bed leveling will go through using an induction sensor on the print head. It will measure the build surface in 9 points to see if there is any deviation in it, and then it will make changes on the fly during the print process to accommodate for those deviations. If you do not have an automatic bed leveling system on your printer, it's not a huge deal. Most of mine do, some of mine don't. This Ender 3 does not have it. How do you get around that then? Well, you're going to manually level your bed. It's not hard. I have a whole video on it. Just for the sake of this video, all you do to change the layer or the leveling on your bed is in each corner is a round dial. Rotate it one way, it's going to lift that corner up. Rotate it the other way, it's going to drop it. You're just going to adjust those until you have an even surface. It's easy, it's not that big a deal. I don't even miss it on my printers that don't have automatic bed leveling because I've been doing it for so long. So don't let that be a deal breaker for you. Some people it is, they insist on having a printer that has ABL, or if they buy something like this Ender 3, they buy an ABL kit for it and put it on. I own a couple of these. I haven't bothered with it because I really don't mind just twisting a knob. Now, other things that you're going to see mentioned in printer descriptions, these are absolutely non-essential to the print process, are things like filament sensors. That just senses when your filament has run out and pauses your print. Do you have to have it? No. What do you do if you don't have it? Well, if you don't have it and your printer runs out of filament halfway through the print, it just is going to keep moving along the tool paths thinking it's feeding filament. You're going to come back to a model that's only half completed and you have to throw it away. Well, how do you get around it? Well, if you're going to print a model out and you're not sure you have enough filament left on the roll, swap rolls out, put a fresh roll on. Not a big deal. Or if you're going to be around when it's printing, keep an eye on it. When it gets close to the end, manually pause the print, swap the filament, and hit resume. Again, common sense, not a big deal. I only own one printer with a filament sensor, and I rarely ever have a reason to use it because I swap out before I begin the prints. That's pretty much it for features you're going to see. The only other thing you may see mentioned on some things is what's known as an all-metal hot end. All you need to know about that is you don't need it printing PLA for desktop models for tabletop games. All metal hot ends are simply hot ends that can be heated to a much higher temperature range for more exotic filaments, but printing at home, you're probably not going to want those. The standard hot ends that come with these printers are going to be just fine for anything you do, so don't worry about that. Okay, so now that we've talked about commonly asked questions and taken a look at the hardware available, let's actually look at the print process for taking a model you've downloaded from the internet and getting it ready to print out on your home 3D printer.
Okay, once you have a model downloaded from the internet that you want to print on your 3D printer, it's going to need to be converted into a language that your printer can understand, in this case G-code. Your model that you download is in STL file format. Now, STL is simply the universal language that all 3D models are saved in, or most of them that you will download. That's going to have to be converted because it is only a description of the volume and outer geometry of your model. It doesn't contain any of the print information necessary for your machine to actually reproduce it as a three-dimensional model. Now, to do that, you're going to use a piece of software called a slicer. In this case, I'm using Cura. Now, what does a slicer do? Well, it's exactly what the name implies. It's going to take your 3D model and slice it up into individual layers or tool paths that your printer will then use to follow when extruding plastic to recreate an accurate representation of it as an actual model. Here in the interface for Cura, in the upper right hand corner, I'm selecting what printer I'm using, in this case an Ender 3. I'm going to select the type of plastic I'm using, which is PLA. And then below that is the basic user interface. It also has a lot more advanced features for once you've gotten accustomed to how it works, and you can select these and fine-tune them to get the best possible quality off your printer. But to begin with, you can just use these basic ones to get you started till you learn how everything works. You can designate your layer height, infill if you need it. In this case, it's set to 10% by default. If you have a print that needs supports or additional build plate adhesion, you can just check those boxes. Once that is done, you're going to want to load up the model you're going to print into the virtual print bed on the screen. In this case, I'm going to open up a dungeon wall tile. It's going to appear as a scale model in relation to the print bed you're seeing on the screen. That print bed is an accurate representation of the print bed for the printer you've selected in the upper right hand corner. In this case, I could probably fit about 9 of these dungeon tiles on my Ender 3 print bed to print at a single time. For the sake of this demo, I'm just going to have one. I'm going to go ahead and click Prepare in the bottom right hand corner. This is telling Cura to go ahead and prepare the individual slices of the model for printing. Once it's done, it's going to give you an estimate of the time. In this case, it's roughly 2.5 hours to print. It's going to use about 7.5 meters of filament and run about 49 cents. Now, the reason it's costing a little more than the usual 40 cents or so is because that 10% infill. Now, this dungeon tile is designed to print with no infill. Infill is simply an interior structure to give it more rigidity. This dungeon tile doesn't need it, so I'm going to set it to 0, reslice it, and now it's showing a print time of only 2 hours and 15 minutes and a price of about 42 cents. So, what has happened here? Cura has gone through and created an individual image of each slice of this model that the printer is going to use. In this case, you can see each individual tool path, the directions that the print head is going to take for extruding the plastic, and it's going to go through. And Cura does this very, very cleanly. It does it very nice. Cura has now prepared one of these slices for each individual layer of the model based on the layer height you selected when preparing the model for slicing. So if I go through here and let's click this and slide up, you're going to see a representation of how your printer is going to create this model layer by layer. It's going to build it up starting at the base plate all the way to the top of the dungeon tile, and that's how your printer works, one layer at a time, following these tool paths. Now you're going to click that button in the bottom right hand corner and export the model to your hard drive. From there, you can get it on your printer either via a USB cable or putting it onto an SD card and inserting that into your printer. Once you have the G-code loaded on your printer, all you need to do is, using the LCD screen on your printer, navigate through the menu, select the model that you wish to print, and tell it to proceed. At that point, the printer will preheat both the nozzle and the print bed. Once that has completed, your print will begin. Now, stick around for the first layer. You're going to want to make sure that it adheres properly to the print bed and doesn't break loose, causing a failed print. If it does, simply stop the printer, clean off the first layer plastic, and then start your print again. Once you know that first layer has stuck, you no longer have to babysit the printer. You can go off and do something else and simply come back once your print has finished.
Okay, so that is 3D printing in a nutshell. Now, if you would like to learn more, if you'd like to get some more information on some of the topics I've covered here today, click the subscribe button in the bottom right-hand corner of your screen. Check out my other videos. Finally, in the description for this video is a link to DrivethruRPG for a special sampler pack bundle from us at Fat Dragon Games and some of the other great publishers on DrivethruRPG. This bundle pack has terrain and miniatures in it for you to try out printing on your new home 3D printer and get you up and running as soon as possible at a great discount. So again, thank you for checking this video out. I hope I've answered some questions for you and at least gotten you thinking about making your own terrain and miniatures at home on a 3D printer. Thank you.